Two very small balls are suspended from the ceiling. Ball A has a mass of 3 kilograms and is on the end of a 2-meter string. Ball B is similarly mounted, but has a mass of 1 kilogram. Ball B is initially at rest. Ball A is lifted until the string makes an angle of 45 degrees with the vertical, and then released. The balls collide in a perfectly elastic collision. What is the speed of ball B after the collision? Take g to be 9.81 meter per second squared. Considering the conservation of mechanical energy of ball A, MAGH equals 1/2 MAUA squared. Eliminating MA, you get GH equals 1/2 UA squared. The height difference is 2 times the difference of 1 and cosine 45 degree. After simplifying, UA equals the square root of 2 times G times 2 minus the square root of 2. Considering the conservation of momentum of ball A and ball B during the collision, MAUA equals MAVA plus MBVB, making UA the subject, UA equals 3, VA, plus VB all divided by 3. Considering the conservation of kinetic energies of ball A and ball B, you will get this equation. After simplifying, 3UA squared equals 3VA squared plus VB squared. Substituting UA into this equation, you will be able to reach this step. You can pause the video to read how I reach the final step, VB equals 3VA. Then, substitute VB equals 3VA into UA equals 3VA plus VB all divided by 3 and make VA the subject. You will get VA equals UA over 2. Finally, substitute the value of UA into VA equals UA over 2, and you will get VA equals 1.70 meter per second, corrected to 3 significant figures. Then, VB equals 3 times VA. The numerical answer for VB is 5.09 meter per second.